Hello everyone, and thank you for joining our webinar today. My name is Jarrett Trotter. I'm one of the application engineers here at Concepts in Production in Amory, Mississippi, and I'll be your guide today as we talk about an introduction to SOLIDWORKS Sheet Metal. So this is kind of just an introduction to the SOLIDWORKS Sheet Metal module, but hopefully there'll be some things in here that maybe you didn't know if you've been working with sheet metal for a little bit. So just want to give you guys a little bit on the agenda today of what we're going to be talking about. First, we're going to talk about what is sheet metal. So what are some of its characteristics and what it can kind of be used for. We'll then go into modeling sheet metal and look at some of the different features that you can use to go ahead and use that within SOLIDWORKS and how you might be able to apply that. And we're also going to look at how sheet metal can be used in industry, so how it might be used within your organization or perhaps how you might use it down the road. So looking at some of the characteristics of sheet metal. Sheet metal is essentially a thin plate of metal, so it makes it a little bit different from other type metals. It can of course be made from different materials, whether it be aluminum or another type of material, but one of the main characteristics is that it is thin walled. So you're typically going to see sheet metal being thinner than a quarter inch. Quarter inch is actually a bit on the thick side. So if you'll take a look at the diagram here, you'll see that some examples here in comparison to like the human finger and how thin sheet metal can be. And the way that we measure sheet metal is using the gauge system, and that's a non-linear metric that's used to define how thick sheet metal is. You'll notice here in the diagram that as the numbers actually get larger for the gauge, then the thickness of the material is smaller. So the 16 gauge sheet metal, as an example, is going to be thicker than the 24 gauge, as an example there. And the 16 gauge there is about 50 thousandths of an inch, 51 there. So being thin walled is the primary characteristic of sheet metal. And another characteristic is the quarter bends of sheet metal. So like in the part that we showed here at the outset that was on the title page, you've got your various bends in a sheet metal part, and there's always going to be some type of radius there along those bends. So these aren't the corner bends, but these are kind of the edge bends that you'll see there along the periphery there, and there's a little bit of a fillet to it. And then on the corner bends, you'll see that there's like a little relief cut. There's a little section there that's cut out so that it can bend easily, and that's done across the industry where you can insert that and the sheet metal will actually fold easily. And what you're looking at here is actually an improvement that took place within SOLIDWORKS and in handling sheet metal between 2017 and 2018. Previously, these relief cuts could only be done within the flat pattern, but now we can actually do them in the folded pattern as well. So it gives you a little bit more flexibility, and it may actually reflect better how you actually make your sheet metal part within the factory or within your organization. And a third characteristic of sheet metal is the flattened configuration. So when you're making your parts, you start out with just a flat sheet, and then it will be bent in various locations to get the desired shape that you want. Now, since we're talking about the flattened configuration, let's delve into that a little bit more. When you're looking at the flattened configuration, particularly in SOLIDWORKS, you'll see that there's a bounding box around it that kind of gives you the dimensions of the biggest shape that you need, or rather the smallest shape that you need to cut out your part, and then it shows you the bend lines and things of that nature. But in going between your flattened configuration and then your folded configuration, which is the primary ones that you would need, and you'd also need, in some cases, maybe the intermediate steps as well. So for instance, folding this part up, then folding this one up as well. What you're going to find is that you're actually deforming the material a little bit and going between that flattened and that folded state. So sheet metal has to be able to handle that. You have to be able to calculate that somehow. And SOLIDWORKS does a really good job of doing that by factoring in the bend allowance. So bend allowance is what enables you to get accurate dimensions whenever you're doing your sheet metal, so that those parts come out to spec after you've burned the part. And under the category of bend allowance, there's actually 3 different categories, or 3 different ways that that's calculated. Those being the K factor, bend allowance, and bend deduction. And we'll talk about those in a little bit of detail. And I'll just direct your attention to the little graphic there on the right. This is kind of a 2D sectional view of a sheet metal part, and there's a few characteristics that are always there within any sheet metal part that's being bent. So you'll notice that there is a neutral axis here that goes at some depth along this thickness here. And what that represents is the material that's not being deformed. So you'll see on this inside bend here that this little radius is smaller. So this material here is being compressed, and then here on the outside when it's bent, this is actually expanding some. So somewhere along there is a line that represents material that's neither compressing nor expanding, and we call that the neutral axis. And we can use that information to get exact or really close measurements on the actual length of the flat pattern and then of the bended part as well. So when we use a K factor, we're using the distance to the neutral axis at this depth right here, and that's just a ratio of it to the material thickness. So if this neutral axis is halfway between that thickness, then the K factor would be 0.5, and then that can be used to get your measurements accurately for the flat pattern. The next way to calculate the bend allowance is called bend allowance. Bend allowance is kind of a sweeping term for all 3 of these, but what the bend allowance method does is it calculates the flat length by getting the straight sections indicated by Y and X here, and then it adds in the bend allowance here that's offset from this inside radius. So these 3 sections kind of add up to give you the flat length there. And then the third and final way is using the bend deduction method. So with this, the flat length is calculated with an extended version of these Y and X dimensions, actually going past that curvature and getting the X and the Y components of this bend respectively, and then subtracting out a portion of that, because of course this Y plus this X dimension is longer than the actual flat pattern. So it's those 2 added together and then subtracting a function of this bend angle here. K factor is the one that's used most often, more than not in industry. Now, going on and looking at sheet metal and how it's used in SOLIDWORKS, it's completely integrated in SOLIDWORKS. It comes within every seat, whether it be standard, professional, or premium, or office. It's in every single one of them. And it easily combines with your non-sheet metal parts. So if you're doing weldments, or if you're making parts through the traditional method without any of these modules, you can combine sheet metal to make multi-body parts or assemblies or what have you. And what you'll see within SOLIDWORKS is that it's actually a tab. We've gotten a call on several occasions when customers are asking, where is it? Is there something special that needs to be done to activate it? And what we'll see, and I'll show you this in the software as well, all you'll need to do is come to one of your tabs up here. If it's not showing, just right click on it and then enable that add-in by selecting sheet metal. Now, there's a few different approaches that you can take to modeling sheet metal, one of which is to design from the flat. So you just start out with a rectangular or flat piece of sheet metal in your base part, and then you bend that part, then you insert bends into it. The next step, or the next approach, is kind of a step above that, which is using the flange method. So by using the flange method, you kind of get the primary profile of your sheet metal pattern. You do an extrusion and then you apply any other bends that you would need to add on to that. There's also the approach of inserting bends. So if you have a part that resembles sheet metal already, then you can just insert some additional bends in there to get those additional sheet metal features that you want. And then finally, you can do convert to sheet metal, where you may have a solid body that you just need to hollow out, select a few faces, and then transform it into sheet metal with that method. Now, the model that I'm going to show you guys today, when we go into SOLIDWORKS, we're going to use the flange method. So we'll begin the primary profile of our part and then designing what's going to be actually the top portion of a computer case by using this method. So we'll go ahead and get into SOLIDWORKS, and we'll just start our part quickly here. You'll see that the sheet metal tab is not available. So like I said earlier, you just right click on one of those tabs, enable that little module, and then there it is. So let's go ahead and start our sketch for our part. And again, we're getting the primary profile, so this is going to be essentially a rectangle basically. And we'll just fully define this, and we want to actually mirror this part, so we're going to create some construction geometry here. Come here and we'll make this 17 inches, say, and then this will be 7 across the top. We'll just grab all of this and then mirror that. And we'll come to our sheet metal tab and we'll click on base flange. So we'll click on base flange and we'll give this some depth here. Let's say we make that 15 inches there, kind of maintain our symmetry. And one of the options that we're going to toggle on is to use a gauge table. And this brings in that information that I mentioned earlier about the different thicknesses that you can associate to your sheet metal part. And the first time that you use this, you'll need to just click the browse button. It'll probably default to the proper location. This is embedded within SOLIDWORKS by default, according to a similar file path as this here. You'll select that folder, and then you'll be able to select which gauge table that you want to use. Now, within these default gauge tables, you have some that correspond to particular materials, whether it be aluminum or steel. You can also make your own gauge tables and insert them into SOLIDWORKS for your use. And once you do that, you can select different things such as the gauge and then the bend radius as well. And you'll see that there's only certain bend radiuses associated with a particular gauge. And there are several different other options that you have there as well. Now, if we go normal to it, normal to this sketch, you'll see a couple of things here. One is that material is being added to the outside of this sketch. You have the option to reverse that really easily within the property manager to reverse the direction. And the other thing that you'll notice is that it's inserted this bend here, so kind of this radius that we've got, because it knows this is going to be sheet metal. So we'll go ahead and click OK, and you'll see that we've got our base flange feature, and then we've got these two bends that have been created automatically for us. So now that we have the major profile for our part, what we can do is actually add in a few more flanges here. I'm going to show you within the sheet metal tab here using an edge flange to add a flange or a little extrusion on the outside perimeter here, just on this side. So I'll click edge flange, and we just simply select one of these edges and we'll drag it out to an arbitrary length. We'll set the length here in a minute. But in addition to just this edge, we actually want to also select these other two. And as I select those, you'll see that they go in the same direction, or they meet up with the other two selections that I've already made. If I select this other side, you'll see that they're all meeting up and converging, and it's actually leaving a little bit of a gap between all three of those. So we'll just make that gap about ½ an inch there, not too much. And we'll go ahead and click OK, and very quickly we've got this little edge flange here. And of course that can be added to bring it out some more. Now, one of the features that I'd like to show you guys that's a little bit more on the advanced side and maybe not as well known is the vent feature. So the vent actually allows us to create a little cutout that's very specialized for that particular kind of geometry. And we'll need a sketch to begin with, so we'll just go normal to this face. Again, this is a vent because this is a computer casing. So we'll just start out by drawing a couple of circles here. We'll go ahead and fully define it. Maybe we bring that up a little bit. Give it a diameter. Put one on the inside here. And then we're going to add in just a couple of spars here. And you'll see how quickly we can make use of this geometry when we go into our vent feature here. So go over to sheet metal, we get our vent, and we can select the boundary of this. And then we can also select these ribs, and once we make all of our selections, then it'll be more obvious the type of geometry that we've got. So you'll see that we've got our little vent here. You can click OK. And now we've got a little vent on the side, and we can actually add in more if we wanted to, more of a circular pattern, more spars if we wanted to, but just one of those little features there that you may not have known about if you have been using sheet metal for a while. And then if we go back to the sheet metal tab, we can then flatten this and we can examine the flat pattern. So you'll see that we have these little construction lines that show us where the bends will take place, and we still have in our little vent here as well. And of course from here you could very easily go ahead and create your drawing. You'll also see that not only can we detoggle the flat pattern here, but it's of course also here in our feature tree as an actual feature that you can suppress and unsuppress. So it's very quickly generating a pretty basic part there in SOLIDWORKS using sheet metal. Now, some of the different applications that you might have for that are the casings like we just used here, so computer casings. You might also use sheet metal for some type of artwork like a sign or something that you might want to put on your door or for your business, and then that can be cut out of course with a CNC mill, something of that nature. It's also really good for cardboard applications because cardboard really resembles sheet metal in the ways that matter in terms of modeling. And then finally, it's really good for fast assembly, particularly with the tab and slot feature that you'll see exemplified here in the bottom right hand corner. You'll see that you've got these little tabs that come out. These actually originate with this part here, and then there are little holes in this part that it corresponds to. And if you're wondering when this came in, this was introduced in last year, 2018's SOLIDWORKS What's New, and that's actually been enhanced a little bit here in 2019. So if you haven't seen this, it's definitely something good to check out if you're looking for manufacturing techniques that allow you to really quickly assemble your components there. So those are some of the things to think about for sheet metal, some of the basic features that you have available to you. If you'd like to know more about sheet metal, we do offer a class. It's a 2-day class on sheet metal here in-house at our facility here in Amory, Mississippi. We can also do that via web meeting, like this GoToMeeting that we have open here. We can do that if you're not able to come on site for training. So I hope that this little webinar has given you guys some insight into sheet metal, whether you're new to using it or if you've been using it for a while and just need to know a few additional things about it. So thank you all for joining our webinar today. Thank you all for coming.